All right, multiplying and dividing complex numbers. So I'll do a quick review of multiplying and dividing complex numbers when they're in rectangular form. So if you're multiplying two complex numbers, you just FOIL. So I do 2 times 1 is 2, 2 times 4i is 8i, negative 3 times 1 is negative 3i, and then negative 3i times 4i is a negative 12i squared. But I squared is negative 1, so this is equivalent to a positive 12. So 2 plus 12 is 14, 8i minus 3i is 5i. So multiplying two complex numbers in rectangular form, you FOIL, you're done, that's it, okay? Dividing complex numbers is when we have to multiply by the conjugate. So this is 1 plus I, or excuse me, 1 minus I. So my conjugate is 1 plus I. I just put a 3 on top here, so I'd have 3 plus 3i, I'd distribute. On the bottom, I'd have to FOIL, and I'd have 1 plus I minus I squared. So those are going to cancel. A negative I squared is equal to a positive 1. So I have 1 plus 1, which is 2. So 3 plus 3i over 2. And if you remember, standard form of a complex number is a plus bi. So this wasn't always accepted. You had to write it as 3 halves plus 3 halves I, just as a reminder. Okay, so this was standard form. So multiplying, dividing complex numbers in rectangular form. Now, multiplying and dividing complex numbers in polar form. You do not have to change them. There's actually a method to this, okay? So, if I have a complex number, and I wrote it out, and then I wrote the abbreviation, r sus theta, and I did r sub 1 and theta sub 1, and then I have a second complex number in polar form, r sub 2 sus theta sub 2. If I'm going to multiply them, my shortcut is, all I need to do is multiply my moduli and add my arguments. Dividing two complex numbers, I divide my moduli and I subtract my arguments, okay? And I put these in written out or abbreviated form for all of those. And again, the abbreviated form is not going to be in your textbook. So, if you are given two complex numbers in polar form, you don't have to convert them to rectangular form to multiply them. This one we're multiplying, so I'm going to multiply these two. 4 times 2 is 8. And then I'm going to add 5 pi thirds and pi sixths. Well, I need a common denominator. So this would be equivalent to 10 pi sixths plus 1 pi sixth, which would give me 11 pi sixths. If they ask for your answer in polar form, there's your answer in polar form, and you're done. There's nothing else that you need to do, okay? You multiplied them, there's your answer. You don't have to do anything else, okay? If they ask you to write it in rectangular form, then you would have to go through and you would have to find that, okay? And they do actually, in some of the directions, ask you to then write it out in rectangular form. So I'm going to keep going, and I'll write it out for you. So the cosine, and again, let me draw a picture. 11 pi 6 would put you in quadrant 4. This is going to be 30 degrees. 11 pi sixths is 330 degrees, so this is going to be pi sixth or 30 degrees. So I've got a negative 1, 2, and square root of 3. So the cosine of 11 pi 6 is square root of 3 over 2. And then the sine of 11 pi 6 is a negative 1/2. And then if I distribute, I get 4 square roots of 3 minus 4i. dividing. I divide my moduli and I subtract my arguments. So I have 3/5 cis pi thirds minus pi fourths. So pi thirds would be 4 pi twelfths. Pi fourths would be 3 pi twelfths. And so I'd get pi twelfths. Now with these, pi twelfths, that one is not a nice angle. This would be another situation where we would have to use the calculator. And again, they're not going to tell you, other than when you look in the back of the book and you see that there's an exact answer, they're not going to tell you one way or the other. You have to be able to recognize, is it a 45, 45, 90, 30, 60, 90 triangle, or is it not? So I have 3/5. If they ask you to leave it in polar form, you're done. If they ask you to convert it to rectangular form, this would be a calculator problem. So you would need to take 3/5 times the cosine of pi twelfths. Oops. And then you'd need to take 3/5 times the sine of pi twelfths. So I'd have, again, rounded to the nearest hundredth, I'd have 0.58 plus 0.16 I.